So thank you for this opportunity to talk here at the PLNOG conference. I'm sorry I have to speak English. Unfortunately, my Polish is very, very limited. And basically, I work for Corient, and there I am responsible for network and technology strategy. And today, I'm going to have the opportunity to talk a bit about a new paradigm for network operation and control, which is part of what we call our Corient hyperscale carrier architecture, which is a network vision that Corient pursues. I don't know if you're familiar with Corient as a manufacturer of networking equipment. We've recently changed our logo and colors to adapt better to the PLNOG colors, which you have up there. And basically, we've done that change because we, as a company, have changed the direction quite significantly to basically adapt to the new world of a transforming network. Now, what is that transforming network? I think we are in an environment where there is an unprecedented speed of innovation in networks that is ongoing right now. We're starting to use very new things like augmented reality. We're using analytics and artificial intelligence. We're starting to introduce self-driving cars, and all these things require communications in a very new way. We all talk about new technologies like cloud to the edge or mesh technologies, blockchain, machine learning. We use Industry of Things and Industry 4.0 and 5G to connect people. And this new environment actually faces a lot of challenges in terms of scaling capacity with an increasing range of video applications, scaling the number of people connected, because that becomes very, very large if you think of Internet of Things or intelligent things connected to each other. Now, how to address these challenges? How to build networks that are cost efficient and power efficient enough to scale? The power efficiency is actually one of the things that shows very well that we have to change how we build networks, because if you look at the world's overall energy consumption, you know what has happened in the last few years? The part of energy consumed by communications has increased. So basically, we in the communications industry are using more than our share of world's energy consumption. And that is something that is quite concerning, because we actually don't want to increase our share of energy consumption. We have to make sure that we reduce that. So besides ensuring scalability and capacity, making sure that we can meet power consumption in requirements, and we can be efficient in power consumption is a very important goal and challenge for us. Another thing that is very, very important is that I think as you scale capacities and you have more things connected, these networks need to be controlled in a more seamless fashion. They have to be more in a new mode of operation where they actually operate themselves, where they are autonomous or cognitive, where maybe networks also become self-learning. And in this environment, we in Corient have a vision which we call hyperscale carrier architecture. We think that a lot of the efficiency and the speed of innovation in networks, as well as the end-to-end seamless operation that we need, the automation in network can actually be achieved by leveraging technologies and concepts that were not developed for the optical network industry, but were developed, for example, for data centers and for the IT industry, and leverage these in how carriers and network operators build networks. Leveraging things such as network function virtualization, as disaggregation, which was first done in data centers, and using them to build carrier networks that are then more energy efficient, more cost efficient, where you can innovate faster, and where you can provide seamless automation. Now, what is the benefit of that approach? Why is that so good? If you look around at examples of technologies and concepts that were developed for data centers, which we can use to build carrier networks, then one of the first things that comes to my mind is actually the area of photonic innovation and photonic integration. As you know, data centers consume, inside data centers, there are a lot of interfaces used, and it's that volume of interfaces that actually drives new technology developments. And actually, a lot of the innovation in silicon photonics, for example, has been driven from the IT industry and from data centers. We leverage that to actually build components for networks that connect data centers, and that we use to also build carrier networks. Another concept that has been around for a long time in data centers is that of disaggregation. Essentially, today's data center are disaggregated, consist of three major disaggregated pieces. They consist of storage, of compute capabilities, and of networking. So in that sense, a data center is always a collection of disaggregated computing functions. And that is something that we are increasingly also leveraging to build carrier networks. Now, if you do that, you also need to control these networks, and this is where the whole networking industry has started to use SDN. Because these disaggregated networks, they basically need another operational environment. And that SDN, along with the disaggregation, is something that not only works for different functions in hardware, like taking apart different hardware functions into separate boxes, but it also can be used to disaggregated software functions, which is the control function itself, the SDN, but there are also virtual network functions that you can run in this disaggregated environment, and which you can use to implement networking functions end to end. I mean, most of this is for all of us quite straightforward. But what is not quite straightforward is the fact that you can take those things and rethink the way you build carrier networks, and through that actually reduce the CapEx and the OpEx, the expenses, easily by more than 50%. You enable new services, and most importantly, you can actually innovate much more quicker in your carrier and network operator environment. Now, how does that work? So, as a next step, I just wanted us all to recall what is currently happening in operators' networks. We are essentially moving both in carrier aggregation networks, in core networks, but also in data center interconnect networks. We are moving from a central office structure, which you can see on the left, with vertically scaling equipment that has a lot of cards to plug in, with functions often integrated into very large boxes that do a lot of things all at once, with a separate operational domain for your IP and PLS and for your transport layers, with dedicated layer 3 hardware, with proprietary firmware and operation systems, and with an an element management and network management environment with LCTs that you run to control individual boxes. Now this central office environment is right now changing, and it's changing very fundamentally into a network that doesn't consist of central offices anymore, but it actually consists of data centers. And what does that mean? Well, that does mean that you follow the disaggregation that was already there inside the data centers, and you use best-in-class boxes for packet networking, for optical interfaces, and also for the optical layer itself, for the WDM. And you combine those and operate them using an SDN environment, which usually consists of a hierarchical stack of different SDN controllers. Now, what does that give you? I mean, that gives you an unprecedented scalability as a horizontal scalability. You don't need to decide up front, now do I install a large or a small box? But you actually install your boxes and stack them and add capacity like that. In order to control this network, you use open APIs and SDN and end-to-end SDN control. You use virtual network functions to make sure that your boxes on a hardware level can stay simpler. And you actually also use an IT-like operational environment, use Ansible, Chef, Puppet, IT tools, software configuration tools that were never used by a carrier before. Now, the key benefit of that is that you can now take those individual functions and drive innovation within those functions. So if you want a more modern set of packet switches, you can exchange those and keep the rest of your infrastructure in place. If you want your next step in capacity in your WDM channels, you can exchange your WDM channels without exchanging all the rest. So you can actually drive innovation much more quickly in such an environment. This actually is very compelling, and that's why I think the whole industry is following that approach. But there's a big question that actually you need to start asking as you install this kind of a network. And that question is, now, what are those functions? What are the right functions for me to use? What is it that what are the functions I want to be able to replace, that I want isolated from each other and want to be able to drive innovation? What are the things I want to keep in place for a longer time? So those questions are quite fundamental, and the answers are not the same for everyone, because the answers are determined by the replacement and innovation cycles you want, sometimes by depreciation cycle of the equipment, so by financial considerations. And they're also driven by the operational environment that is there. Depending on your starting point, it may be very, very challenging to use a fully disaggregated network. But on the other hand, this increasing disaggregation moving to the right has a number of consequences. One of them is that if you don't have those very large boxes that integrate a lot of functionality, then you depend on a single vendor. So basically, vendor lock-in is reduced significantly if you disaggregate your network and buy best-in-class functions which you combine. You can buy those from different companies. You can also increase innovation cycles if you have very small functions that are separate from each other. You can be faster in innovating in a very targeted way. The investment to innovate becomes smaller because you don't need to replace so much of your network all at once. But there's a big if, and that if is, as you move towards the right, you get a lot more different separate functions, and it becomes harder and harder to control and manage those. So the whole complexity of the network increases as you move towards the right. And that's something we tend to forget, as everybody is excited about this trend towards disaggregation. And it's actually managing that complexity, which I think is the key challenge that everybody in the industry is right now facing. We actually, last week I was at the Optical Fiber Communications Conference in San Diego in the US, and there were multiple workshops and conference sections on how to handle that complexity, how to deal with it, how to deal with the fact that all of a sudden there are responsibilities split between many different companies, how to handle this complexity. And I think the key thing here is to establish a new control environment. Basically, to transform the operational environment, do an OSS transformation that allows us to handle this complexity. That is an industry challenge. That's something that we all face. And looking at this control environment from a high level, a very, very high level, you actually see visually that the whole industry is working on it. Because down here we have the physical network functions. We have optical layer functions. We have packet switches. We have their SDN controllers. And you also have virtual network functions and their SDN control. And this is all tied together through some kind of orchestration, network orchestration and service orchestration functions. Now, in this whole space, there are a very large number of standardization activities, of multi-source agreements for different boxes. There are open source initiatives and industry initiatives such as the Telecom Infrastructure Project, MSAs such as Open ROADM, open source software such as ONOS or Open Daylight. So there's ONAP, which actually, where AT&T basically has open sourced their network control software. All these have a common goal, and that is they're an industry effort to try and provide a seamless and simplified integration into an end-to-end operational environment, to make sure that this world of open everything, as I tend to call it, really works. And it's characterized by disaggregation into separate functions, by openness, because in order to make this work, these different elements need to have open interfaces that are well defined, and by abstraction, because as you work through these layers of software up to the top here, a network orchestrator cannot handle all the details of the underlying network. So it's very important that each software layer abstracts the network layers below that for the higher layers. That abstraction is actually the key to handle complexity in these networks. So when people talk about Young model and information models, that is the key to make these networks work, because they make the underlying network look simple, although it isn't. Yeah? Now, with this abstraction, it's no longer the sheer complexity that is an issue, but the challenges really are the ones we are now creating ourselves in this industry. Because as you can see from the picture, there are many of those forums. Too many, actually. We have multiple competing forums, multiple overlapping definitions. We have a lot of open issues to resolve still. But I think it's these overlapping definitions and these competing forums that are the greatest concern of all. And to some extent, this is also a point where I tend to ask everybody in the audience, please help to make sure these things converge. Because otherwise, these definitions will not be open anymore. APIs can be open if you have maybe 2 or 3 flavors of them. If there are 15, then each of them is almost like a proprietary interface, and there's no openness and end-to-end interworking anymore. Now, this is the challenge. Now, the good thing is that I think some of those activities are converging. And I just wanted to look one step deeper into this environment to show you how these things are trying to, or we are trying to help to bring these things together. And these are examples of activities where Corient is active. Now those are the networking layers. This is WDM layer. This is then a layer 1 OTN and transponder layer. This is packet switching, layer 2 and layer 3. And there are different activities that define interfaces that then allow the control of these networks. And one of those is OpenROADM, which defines interfaces that will control mux ponders, transponders, and WDM equipment. Another one is the Telecom Infra project, which has a so-called Common API project, which tries to standardize all those interfaces. Coriant is actually co-leading that activity. We're trying to make sure that these definitions are actually aligned with what OpenROADM does. And besides these definitions that come up from the... That was not me. Besides the definitions that come up from the box level, there are also definitions that are being made down southbound from the controller layer. For example, in ONOS, there's a so-called activity called ODTN, Open and Disaggregated Transport Network. They're defining use cases in this ONOS SDN controller, which also allows you to control the optical layer underneath. They're writing open source software, and they're also defining this API. And right now we're working to make sure that these things don't diverge. It'll be interesting to see whether we succeed with that. Yeah. So you can see a lot of activity. You can see that sometimes there are multiple activities for the same type of open API. We're working hard in this industry to try and bring them together. Now, besides that work of defining APIs and trying to make sure we can end-to-end control this network, I would like to switch to some examples of how we actually implement this network vision, which I think most of the industry shares today. And I'll move to an example of a product which has received a lot of attention in the last year, which is Coriant Groove G30, a networking equipment that Coriant has developed, which actually has been tailored for this environment. So it was never intended to be used in a telecom environment, but it was from the start developed to be used in this IT environment. So it has those abstraction models, information models, Yang-based information models that it uses to represent its functions towards SDN controllers. It's got a netconf and a restconf API to do that. So it ties seamlessly into the SDN environment, which we saw earlier. It can be directly operated by these different open source SDN controllers, such as Open Daylight and ONOS. And it has additional interfaces that will work with different IT tools that are there, with like SNMP alarm collectors, like syslog interfaces, streaming telemetry into analytics databases. And in order to operate it, we use command line interfaces and web GUIs and use zero-touch configuration. So you can see that it basically is something very different from what you would use in a telco environment. And I think it's these interfaces and this operational concept for the equipment, which has been very central in its success in different customer environments. It's today the lowest power transponder equipment on the market. This one rack unit box, you can also look at it outside, has a capacity of 3.6 terabit in this one rack unit box. Each of these here has 400 gigabit per second of capacity, and it uses only around 25 watt per 100 gigabit of transmission capacity. That's industry leading today. And it basically, I think, is an example of the benefit that you can get from this very fast innovation which you can drive in this disaggregated environment. These power consumptions, this footprint, is something you cannot achieve if you build boxes that have a large range of different functionalities all integrated into one. Yeah. I think this is just an example of a piece of equipment that has been tailored for this. We at Corient actually have taken this whole approach and this network vision further because we want it to work. We not only work in these industry environments, we have developed several products that actually fit this environment. One key thing is that we have an SDN control software that actually supports a disaggregated network in a very efficient way. In particular, it also ties in other equipment than our own to make sure that customers are free to choose who they buy their equipment from. I think you'll have here in a presentation later today, you will hear more about that product. We have, as we just saw, we have reduced power consumption and footprint of WDM transport significantly with Groove G30. And it not only is a transponder, so basically providing optical interfaces, but it also integrates a very dense optical line system, which is open to all kinds of different interfaces. And the latest addition to this set of disaggregated products is our Vibe series, which is a series of packet switches that allow you to build a highly programmable IP layer, which is SDN controlled and which also leads in power consumption and density and can provide a very cost-efficient evolution of networks. Now, I hope I've been able to show to you that this vision of a hyper-scale carrier network architecture that Corient pursues is something that is very quickly becoming real in our products, and it's a vision that we at Corient have embraced to enable faster innovation. This is really our overriding goal in this environment. We've come a long way, and there's still a lot to do, in which I'm looking forward to continue driving this evolution. With that, I would like to say thank you all, and thank you for the opportunity to talk here.